Overview and definition of blockchain. A blockchain is a distributed database that maintains a continuously growing list of records that are secured from tampering and revision. It consists of data structure blocks that may contain data or programs, with each block holding batches of individual transactions, and the results of any blockchain executables. Every node in a decentralized system has a copy of the blockchain. The digital ledger is used to record transactions across many computers so that any involved record cannot be altered retroactively, without the alteration of all subsequent blocks. This allows the participants to verify and audit transactions independently and relatively inexpensively. A blockchain database is managed autonomously using a peer-to-peer network and a distributed timestamping server. Elements of blockchain. Distribution. Encryption. Immutability. Tokenization. Decentralization. Distribution. Blockchain participants are connected on a distributed network and operate nodes, computers that run a program to enforce the business rules of the blockchain. Nodes also keep a full copy of the ledger, which updates independently when new transactions occur. Its participants are located physically apart from each other and are connected on a network. It is a database that is consensually shared and synchronized across multiple sites, institutions or geographies. It allows transactions to have public witnesses, thereby making a cyber attack more difficult. The participant at each node of the network can access the recordings shared across that network and can own an identical copy of it. For example, this technology has great potential to revolutionize the way governments, institutions, and corporate work. It can help governments in tax collection, issuance of passports, record land registries, licenses and outlay of social security benefits as well as voting procedures. Encryption. Encryption is the process of encoding a message or information in such a way that only authorized parties can access it and those who are not authorized cannot. The process of converting information from a readable format to something that makes no sense. It does not itself prevent interference but denies the intelligible content to a would-be interceptor. Blockchain uses technologies such as public and private keys to record the data in the blocks securely and semi-anonymously. The participants can control their identity and other personal information and share only what they need to in a transaction. It serves as the basis for blockchain wallets and transactions. Cryptographic hash functions provide the trait of immutability. For example, it allows you to use the blockchain ledger to verify that data you backed up and stored in the cloud with third-party vendors has gone completely unchanged even weeks, months, or years later. Nobody can deny that blockchain offers reliable, independent data verification. Immutability. Immutability can be defined as the ability of a blockchain ledger to remain unchanged, for a blockchain to remain unaltered and indelible. More succinctly, data in the blockchain cannot be altered. Each block of information, such as facts or transaction details, proceed using a cryptographic principle or a hash value. That hash value consists of an alphanumeric string generated by each block separately. Completed transactions are cryptographically signed, time-stamped and sequentially added to the ledger. Records cannot be corrupted or otherwise changed unless the participants agree on the need to do so. This concept can redefine the overall data auditing process and makes it more efficient, cost-effective, and brings more trust and integrity to the data. For example, if I send an email to a large list of friends, that data is immutable from my perspective. To change it, I'd have to persuade my friends each to delete the email. Or, I would have to persuade the email provider, say Gmail, and the companies running all the mail servers of my friends. From my perspective, and with the control I have, that email is immutable. I can't unsend or revoke it without collaboration and risk of detection. Tokenization. Tokenization converts the rights to an asset into a digital token which are stored and managed on the blockchain. Transactions and other interactions in a blockchain involve the secure exchange of value. The value comes in the form of tokens but can represent anything from financial assets to data to physical assets. Tokens also allow participants to control their personal data, a fundamental driver of blockchain's business case. It is a method that converts rights to an asset into a digital token. Suppose there is a $200,000 apartment. Tokenization can transform this apartment into 200,000 tokens. Thus, each token represents a 0.0005% share of the underlying asset. Finally, we issue the token on some sort of a platform supporting smart contracts. For example, the tokens can be freely bought and sold on different exchanges. When there is a total of 200,000 tokens for an asset, you buy one token, you buy 0.0005% of the ownership in the asset. Buy 100,000 tokens and you own 50% of the assets. Buy all 200,000 tokens and you are 100% owner of the asset. It ensures that once you buy tokens, nobody can erase your ownership even if it is not registered in a government-run registry. Decentralization. The decentralized nature of blockchain technology means that it doesn't rely on a central point of control. A lack of a single authority makes the system fairer and considerably more secure. The way in which data is recorded onto a blockchain epitomizes its most revolutionary quality, its value of decentralization. As a blockchain is a ledger of information, it is extremely important that the information being stored is honest and accurate. The data is made even more secure by the fact that there is no reliance on a central point of storage, reducing the risk of it being lost or destroyed. Attacking one point of storage would result in no loss of data since all the information is stored on multiple devices around the world. In this regard, Bitcoin is the most weathered and resilient platform in the space, having withstood barrages of attempted hacks, all of which have been unsuccessful. For example, the foreign exchange market is an example of decentralization because there is no one physical location where investors go to buy and sell currencies. We can use the internet to check the quotes of currencies from various dealers from the world. Use cases of blockchain. Cryptocurrencies. Defense and military. Traditional banking. Internet of Things. Healthcare. Government. Cryptocurrencies. Cryptocurrency is a digital asset designed to work as a medium of exchange that uses strong cryptography to secure financial transactions, control the creation of additional units, and verify the transfer of assets. It is first implemented as the operational network behind Bitcoin. Blockchain is now used in more than 1,000 different cryptocurrencies, a number that grows almost daily. The legitimacy of cryptocurrency purchases by individuals is ensured because they can trace the transfer of the currency to its origin. Encryption helps control the number of cryptocurrencies being created, thus stabilizing value. For example, Bitcoin is the world's most widely used cryptocurrency. It is an innovative payment network and a new kind of money. It is a decentralized digital currency without a central bank or single administrator that can be sent from user to user on the peer-to-peer Bitcoin network without the need for intermediaries. Defense and military. These militaries and defense companies use blockchain's encryption and decentralization methods to improve data security and maximize privacy. The sectors have led to some of the biggest technological breakthroughs in the past century. Blockchain is seen as a legitimate data safeguard for militaries, defense contractors and aerospace companies that house some of the most sensitive information. These militaries and defense companies use blockchain's encryption and decentralization methods to improve data security and maximize privacy. The ability to transmit secure communications between units is one of the fundamental requirements for any military organization. For example, if a shipment goes unaccounted for in the defense sector, the result could be some bad guys ending up with potentially lethal weapons. The stakes are higher when it comes to effectively tracing the weapons, gear, and other items that are essential to facilitating national defense at home and abroad. This makes the companies conceiving the most cutting-edge supply chain oversight platforms on the blockchain some of the most critical blockchain-related innovators. Traditional banking. The tamper-proof, decentralized, immutable nature of the blockchain makes it ideal for reducing costs and streamlining everything from payments, asset trading, securities issuance, retail banking, and clearing and settlements. Wall Street has begun to take notice of blockchain's bolstered security protocols. Traditionally known as slow movers in adopting new technologies, some of Wall Street's largest financial institutions are trying to stay ahead of the curve. Trillions of dollars in cash flow combined with outdated and centralized cybersecurity protocols make the largest banks constant targets of hacking and fraud. For example, the banks are using blockchain technology to process private transactions. They use smart contracts on the network to implement transparent yet cryptographically assured transactions. They have a patent for Know Your Customer processes that enables the bank to store all personal identifying customer information on a secured blockchain. Internet of Things. The Internet of Things is a growing industry full of innovation, creativity and, consequently, cybersecurity issues. Nowadays, IoT products can be found in almost every aspect of our lives. There have been thousands of reported IoT device hacks over the last few years. As the IoT device market continues to grow, so too does the need for an enhanced form of cybersecurity. Blockchain provides a safe infrastructure for the transfer of data from one device to another without the interference of malicious actors. Decentralized control enables IoT devices to create audit trails and tracking methods for registering and using products. For example, smart Internet of Technology-enabled devices plays a crucial role in our day-to-day lives. They enable the home security system to be managed remotely from the smartphone. Blockchain elevates the smart home to the next level by solving security issues and removing centralized infrastructure. Healthcare. Blockchain could be the badly needed solution to a problem that puts patients and hospitals at severe risk. The healthcare industry endures a constant barrage of cyber attacks. In fact, healthcare experiences twice the amount of phishing emails and malware attacks of any other industry. Not only healthcare companies, hospitals, doctors and clinics store patient banking information, they also possess important health records. Patient data is important to cyber criminals because it demands much more money on the black market. Credit card information is constantly stolen, but modern technology typically resolves any damage quickly. For example, some hospitals have worked with dozens of healthcare companies and hospitals to build secure digital blockchain networks for patient information sharing and internal communication channels. They use AI to discover and analyze all aspects of the healthcare system, including operational, administrative and medical data. It then implements blockchain to secure the massive amounts of data collected. Government. Blockchain is best known as the foundation for cryptocurrencies, but the distributed ledger technology can be used in an array of applications that are being explored by governments around the world. The entire system runs on safe encryption of information, essentially putting a barrier between hackers and identifiable information. Encrypted data, decentralized information storage, and publicly visible ledgers can instill a new set of government cybersecurity priorities. Agencies would be able to quickly identify potential hacks and trace the manipulated data to its origin. These governments and agencies, in attempting to be among the first governmental blockchain adapters, are pioneering ways to implement distributed ledger technology into everyday cybersecurity protocol. For example, digitizing most of the paperwork that the government is required to keep on hand but rarely uses would be a purpose worthy of blockchain technology. Serving as a permanent, non-space consuming record of marriage licenses, arrest records, and much more, the blockchain could reduce entire buildings and personnel departments to remnants of the archaic past. Illustrative example: Ethereum, IBM blockchain, IOTA, multi-chain, Ripple, i3 Corda, Quorum.